Atlas Boeing 767 Cpat review of the DC electrical system. The DC system contains two bus tiebreakers that only function if both the AC bus tiebreakers are in auto. The left DC is the normal source of power for the center DC bus, the standby DC bus, and the battery bus. Loss of all AC, including the hydraulically driven generator, causes a reversion to battery and standby power, which powers four buses. The four buses are the hot battery bus, the battery bus, the DC standby bus, and the AC standby bus, which is powered by an inverter off of the DC standby bus. The hot battery bus is powered without the APU external power for engine generators. It is powered in the battery. If any other generators are operating, the hot battery bus is powered by the battery chargers. Systems that need continuous power are powered from the hot battery bus and include fire extinguishing and fire extinguishing electrical, SPAR and APU fuel valves, IRS emergency power. The left and center is continuous, the right is on for 5 minutes. The RAT ram air turbine manual deployment, the clock time reference, alternate landing gear extension motors, equipment cooling, ground warning and automatic testing, the ground fueling system, and the parking brake valve. The battery bus without generator electrical power can be powered by the hot battery bus by selecting the battery switch to on. Battery discharge light will illuminate. With generator power available, if the battery switch is not on, the off light will illuminate and an ICAS battery off message will occur. Battery bus powers engine and APU fire detection, DC fuel pump, the ram air turbine automatic deployment, standby engine indicators, the anti-skid for the inboard wheels, engine anti-ice valves, engine fuel valves, engine high pressure bleed valves, the engine driven hydraulic pump shutoff valve, the engine start controls, cabin service interphone, flight interphone, equipment cooling test and smoke clearance, fuel crossfeed valve, the fuel quantity system, generator controls, indicator light tests, landing gear sensing systems, PA and passenger oxygen systems, and wheel well fire test. Standby power, as noted earlier, without generator power, is powered by the DC, or includes the DC standby bus, the AC standby bus powered through an inverter, which are both powered by the battery with the battery switch on, and the standby power switch in auto or battery. With generator power, the left AC bus through the left AC transfer bus powers standby AC. If the standby AC bus loses power, the standby bus off light illuminates and an ICAS message standby bus off appears. The standby AC bus provides power for the left VOR, the left ADF, RDMI, the center ILS receiver, the main instrument panel floodlights, the bleed air isolation valves, cabin altitude and differential pressure indications, left yaw damper, standby ignition, standby instrument lights, 3 of the spoiler pairs, and wheel well fire detection. Standby DC without generator power is powered by the battery through the standby power switch when it is in auto or battery. With generator power, the left DC bus is the primary source with battery as a backup. If the standby DC bus loses power, the off light illuminates. The standby DC bus powers the standby attitude indicator, left VHF comms, manual cabin pressure, bleed air isolation valves, automatic flight warnings, Cat 3 isolation, left oral speaker, left column vibrator, left yaw damper, rudder trim and control, and the stab trim shutoff valves. Placing the standby power switch to battery isolates the system from the battery chargers so that it relies solely on battery power. The discharge light will illuminate, but the off light remains out. This concludes the DC electrical review.